72,000 people died in 2019 because of lungs related ailment. Good morning to one and all present here. I am Bianca R from ECE department, first year, and I'm here to share my research topic, analytical approach of the effect of surfactant on mixed metal oxide materials to enhance the efficiency of humidity sensors. My supervisors are Dr. S. Tirabhavani ma'am and Dr. M. Gulam Nabi Al-Sad sir. This is a brief overview of everything I'm going to be talking about. So, introduction. We all know what exactly a sensor is. A sensor is a transducer device that converts a physical parameter and produces electrical signal as output. Based on the signal, various inferences can be made. The sensor is classified into two different types based on the quantity that is being measured: physical sensors and chemical sensors. uh, if the sensor measures a physical parameter, then it is called as a physical sensors. Like humidity sensor is also a type of physical sensor. Okay, so what exactly is a humidity sensor? A humidity sensor is an electronic device that measures the humidity in the environment and converts its finding to the corresponding electrical signal. Based on the principle used, humidity sensors are of two types: relative humidity and absolute humidity. Relative humidity is calculated by comparing the live humidity at a particular temperature to the maximum possible humidity at the same temperature. Absolute humidity is the amount of water vapor in 1 centimeter cube of air. The major applications of humidity sensor are in the medical and the manufacturing industries. Respiratory rate and the working of the lungs can be studied by the humidity sensor, and like in cooling processes, automation of temperature of cooling devices like AC and fridge can be done based on humidity levels using humidity sensors. So here is the working principle of the humidity sensor. So the nanomaterials are chosen in such a way that their resistivity varies change in uh, like with change in relative humidity in the environment. ZNO is a N-type semiconductor material and NiO is a P-type semiconductor material, which is going to act as the major constituent in this semiconductor sensor. So they are mixed in the hydrothermal processes, which increases the adsorption sites. When oxygen fills this oxygen valency, movement of electrons and ions is going to take place, which causes generation in electric current. And the resistance value decreases based on this current generated. The humidity level can be measured. Here, 7 is the humidifier, which is going to act as the source, which will be replaced by the original source from which we'll get the humidity. Then 8 is the cylinder containing nitrogen air, which is used for emptying this chamber and for removing all the impurities present in this chamber. So number 9 is our uh, humidity sensor, and number 10 is going to be the reference sensor, which is DHT11, and LCR meter is connected, which is number 6, to measure the inductance, capacitance, and resistance, but we'll be mainly measuring the resistance. Then it is connected to the LED display unit, which is a 7-segment LED display unit for measuring and showcasing the live uh, humidity reading. Arduino Nano microcontroller is connected to it, which converts the analog data that is being generated, which is of continuous waveform, to digital data, which is of discrete waveform. It is connected by R232 serial port to the laptop. Arduino Nano microcontroller handles data management via cloud computing. So, nanostructure. So, like any structure that has its size from the range of 1 nanometer to 100 nanometers is said to possess the nanostructure. Advantages of nanostructures being it's smaller, faster, lighter, cheaper, less raw materials, consumes very less energy, and it has very large surface to volume ratio, which means increased efficiency. Metal oxide. Metal oxide happens to be a very important part or many a very important constituent in our humidity sensor. And metal oxides are crystalline solids that contain the metal cation and oxide anion. Their properties being highly stable, highly reactive, highly selective. Their ability to react to only a particular stimulus when placed in an environment, high regenerability, robustness, that is like they can withstand and overcome adverse working conditions, and also low cost as they are easily available. Why are we using metal oxides? There is a strong interplay between spin charge and lattice. By like altering one quantity, other two quantities can be easily modified. They have a wide variety of crystal structure. For example, ZNO nanocrystals can take cubic, rod-like, and hexagonal structures. They can have the nanostructuration. They have transport properties which can be useful for transporting the electrical signal that is generated. They can be doped for altering properties like optical, structural, morphological, and electrical. And NIO is used for doping ZNO, and ZNO happens to be an N-type semiconductor material, and NIO is a P-type semiconductor material. Why exactly are we using ZNO when the choice of metal oxides are here? Because of good transparency. Thin films of ZNO act as good transparent conductors with high transmission of optical signals and high conductivity of DC currents. And high electron mobility, wide band gap. The band gap of ZNO is really large. By doping it with NIO, the band gap reduces considerably, which makes the sensitivity of the sensor more. Boiling point 2360, melting point 1975. It is non-toxic. Integration of ZNO with other metal oxide with NIO further increases ZNO's sensitivity and moisture measuring properties. High specific surface area and more oxygen vacancies make ZNO more sensitivity towards humidity and gives it excellent performance. There are three different methods for the fabrication of the humidity sensors, being hydrothermal method, doctor blade method, and the spin coating method. Hydrothermal method is used for generating ZNO crystals of desired structure. Zinc acetate dihydrate and nickel acetate dihydrate of 0.5 grams is mixed with 60 ml of DI water, and then the novelty of this method, surfactants is going to be added. Hexadecyl trimethyl ammonium bromide and SDS, which stands for sodium dodecyl sulfate, are added to the solution, and by magnetic stirring we are obtaining a like solution which is heated in the Teflon lined SS autoclave for 20 hours at 120 degrees Celsius, which will yield us like nanostructures with a specific structure, which happens to be hexagonal structure in this case. Then we filter out the DI water, and the crystals obtained is annealed at 100 degrees Celsius for 24 hours and calcination at 350 degrees Celsius for 2 hours. Then finally, we are getting ZNO NIO powder by the Morker pistol method, which is used to make the particles into finer particles. Then alpha triphenol solution is mixed with this powder to obtain a paste-like structure. Now we are going to see the Dr. Blade method. Dr. Mead method is a technique used to form films with well-defined thickness. So firstly, the FTO coated glass subface is clean. FTO stands for fluorine tin oxide and masked out, only leaving the area that must be coated on by the nanoparticle. The nanoparticle suspension is applied and spread to the areas using a blade running to and fro in the over the surface. Then a fine ZNO-NiO nano layer is obtained. The layer formed is few micrometers thick because it happens to be done manually in Dr. Blade method. Then it is allowed to cool and settle. In spin coating method, the same method is as the Dr. Blade method, but it is done by the machine. The substrate, FTO coated glass substrate, is placed in the machine and the nanoparticle suspension is applied. When the machine is turned on and it starts rotating, the nanoparticle suspension excess in amount is thrown away and the zinc NiO nano layer is obtained when it is heated and allowed to cool, but this layer is only few nanometers thick because it is done by the machine. After the ZNO-NiO nano layer is formed, P.PSS solution is added by a micropipette which will act as the P side and this substrate along with the ZNO-NiO nano layer which act as the N side. P.PSS stands for poly 3,4 ethylene dioxide thiophene polystyrene sulfonate, which is used for its thin surface and high conductivity. So, research objectives. So, the main novelty of the study is the use of surfactants. Surfactants are surface reactive agents. Substances, when added to liquids, reduce their surface tension and uh, increase their spreading properties and wettability. So, to increase the sensitivity of the humidity sensors, surfactants hexadecyl trimethyl ammonium bromide and sodium dodecyl sulfate are added. By adding the surfactants, the vacancy of the oxygen atom is increased. Therefore, it increases the sensitivity of the humidity sensor. Adding surfactants increases the surface area. Therefore, the sensitivity and efficiency are increased. And surface to volume ratio is also increased. So literature survey. Before literature survey, the major factors considered for the fabrication of the humidity sensor is sensitivity, selectivity. The sensor should measure only the humidity and should not be affected by any other parameter present in the surrounding. Repeatability, how it can be easily repeated. Linearity, low hysteresis loss and high lifespan. So in the first paper, improvement of humidity sensing performance. The material used is calcium copper titanate. They have tried to improve the response by altering the porosity and grain size. They've studied the effect of the response in pH change. Relative humidity is in the range of 33 to 95% is being measured using this particular humidity sensor, but the sensor that we are going to make can measure humidity, relative humidity from the range of 10% to 97%. The next paper studies the application of mixed metal oxide composites on humidity sensing. They have used zinc oxide nanosheets. They have aimed in minimizing the response time and the recovery time. In our case, the response time is going to be less than 20 seconds and recovery time 2 seconds. But the response time in their case is 25 seconds and recovery time is 5 seconds. Hydrothermal synthesis and characterization of ZNO particles of various shapes under reaction conditions. Here they have studied in detail how hydrothermal process and the final product that is being formed in that process, and the morphology largely depends upon the temperature of the autoclave, the time for which the autoclave is being operated, and the concentration at which the solution is being kept. On paper number 4, electrical, photocatalytic, and humidity sensor of mixed metal oxide materials is studied in great detail. Electrical and electronic devices are operated based on dielectric characteristics. There is a change in resistance with respect to the variation in the relative humidity levels. In paper number 5, nanoforest based humidity sensor to determine the resistive respiratory rate using humidity sensors is done. But here mixed metal oxides are not being used. Three lever capacitance and parasitic capacitors are being used. In paper number 6, ZNO SNO2 humidity sensor. Humidity is measured by resistance sensor hysteresis loop. Paper number 7, which is not exactly a humidity sensor, it is the surfactant assistant synthesis of NiO, ZNO nanoparticles and NiOCuO nanocomposites for the enhanced photocatalytic degradation of methylene blue under UV light radiation. The energy bands of pure ZNO, NiO, and their mixture has been studied in great detail in this particular paper. In paper number 8, humidity sensing properties of copper-based humidity sensors, change in resistance of sensing materials is used to calculate the relative humidity in the surroundings. Geochemical reaction cause the impedance change, and the grain size affects the moisture sensing properties. If the particle size is reduced, then the specific surface area is improved, which means increased efficiency. This one, paper number 9, is also not related to humidity sensors. It is effective heart rate prediction using hybrid machine learning techniques. It is effective in assisting in decisions and prediction from a large quantity of data using machine learning algorithm and Internet of Things. In paper number 10, synthesis of ZNO, NiO, hollow spheres, and humidity sensing performance, oxygen vacancy, and ion conduction improves the humidity sensing performance. So generally, the inferences from the literary survey being grain size, surface area, and porosity are contributing to the better sensor response. The morphology and structure of the nanomaterials, which are produced by the hydrothermal process in the autoclave, largely depend on the temperature, time, and the concentration of the solution. In hydrothermal synthesis, under different reaction conditions, the different shapes of ZNO particles, nanoparticles can be formed as per our requirements. In our case, we are going to go for hexagonal shaped ZNO particles. The change in resistance with respect to variation in relative humidity can be used to calculate the selectivity and sensitivity of the sensors. Band gap can be modulated through the concept of mixed metal oxide composites, as we already discussed. So here is the workflow: start, requirement, synthesizing process, fabrication process, verification. If the product that has been synthesized has high value of sensitivity, selectivity, and high efficiency, then it is approved and that is the end, or else we are going to optimize it to make it better. And here is the timeline of various activities and conclusion. Fabrication and implementation of humidity sensors for respiratory monitoring application. High sensitivity, linearity are the two important parameters that are being considered for the efficiency of the sensor. And data monitoring and management can be carried out by using machine learning algorithm and information of things. Thank you so much for listening.